After Ørsted's discovery of the magnetic effect of current in a straight wire, another great scientist, Ampere, found that the magnetic effect could be increased if the wire is bent in the form of a circular loop. I am sure you will be curious now to know about his observations, right? Okay, let's make this interesting. So let's take a long wire and bend it to form a circle. We would also need a cardboard here. Now arrange it in such a way that the wire passes through this cardboard like this. But while doing that, make sure that half the wire is above the cardboard and the remaining part of the wire is below the cardboard. Then join the free ends of the wire to a battery through a key. Before you plug in the key, let's sprinkle some iron filings on the cardboard. Why are we doing this? It's because we want to understand more about magnetic field due to the current through a circular loop. Now we plug the key and allow the current to pass through the wire. What do we observe? Wow, the iron filings have emerged into concentric circles. Amazing, right? What else do you observe? We see that the concentric circles are centered at the point where the wire passes through the cardboard. Yes, concentric circles have formed at these 2 points. Anything else you noticed? Yes, we can see that the lines near the center of the loop are almost straight. Not entirely straight, but almost straight. But what does this mean? It implies that the magnetic field at the center of the loop is perpendicular to the plane of the loop. Understand this line well. If you look at the plane of the circle in front of you, the magnetic field lines at the center are coming straight at you. It's perpendicular to the plane of the loop. So we have observed the magnetic field line patterns. But I think we need little more research to find out the direction and the strength of the magnetic field. Okay, first, direction of the field. To find the direction, you'd have guessed that we will be using the right-hand rule. If you look at the circle in front of you, the current is traveling from the right to the left along the circle. The direction of the current on the right side of the wire is upwards. So if we point our thumb upwards and roll our fingers around it on the right, we get the direction of the magnetic field here. It will be anti-clockwise. And applying the same rule on the left, we get the direction of the magnetic field to be clockwise. That gave us an idea about the direction of the magnetic field. But what will happen if we reverse the current flow? We change the orientation of the battery and make the current flow in the opposite direction. Which means the direction of the magnetic field changes when the direction of flow of current is reversed. Okay, now we just have to find out about the strength, right? That's very simple. We are going to repeat the same experiment by increasing the strength of the current. We see that on increasing the strength of current in the conducting wire, the number of lines of force around it increases. One last important thing. Even by increasing the number of turns of the coil, the number of lines of magnetic field around the coil increases. Amazing, isn't it? So here in this session, we have observed the pattern of magnetic field, its direction and its strength. Stay tuned to learn more about the real magic of magnetic effects.